Hello everyone, so you're welcome to my YouTube channel, and in today's class we'll be looking at differentiation by product rule. Okay, so the product rule is used to differentiate the product of two functions. Okay, so the product rule says that when y is equal to uv, so divide the x, which is our change in y over change in x, will be equal to v du over dx plus u dv all over dx. Okay, so the product rule is to differentiate the product of two functions. Someone could say, okay, how about we take the product of those two functions and then before we differentiate? Yeah, that's very fine, and it's true. If you have a case where it's a polynomial, like this case, both of them are polynomials, right? So you could easily multiply through, you could easily take their products and then you later differentiate by direct method or by first principles, right? But how about you have cases of special functions, like where you have tan x, where you have e raised to the power of x? Those things are series, right? They are series, they are non-stop. If you want to expand these things, they are non-stop. Okay, by Maclaurin series or by Taylor series, these special functions are non-stop, so you cannot actually take their product easily. So the product rule is your safe route, right? So we're seeing how we are going to use the product rule to differentiate functions, right? So for question number 1, it says y is equal to the product of 3x plus 5 multiplied by 20x squared plus 5. Okay, so the product rule says divide the x is equal to v du over dx. So divide the x is equal to v du over dx. And what's our v? Our v is the second function, so you can call this u and call this v, right? So v du divide the x. So this is 20x squared plus 5 multiplied by the derivative of the first one, right, which is just 3. If we differentiate 3x plus 5, we'll get 3, right, plus u, which is 3x plus 5, right, multiplying by the derivative of 20x squared plus 5. The derivative of 20x squared is 40x, right? So we can expand this to be equal to, divide the x is equal to 60x squared plus 15, right? Plus 120x squared plus 200x, right? So we could take like terms, x squared, so that will become 60 plus 120, which is 180 x squared plus 200x plus 15, right? So that's the derivative of that function, right? That's the derivative of that function. We'll go to question number 2. That y is equal to x squared tan x. So this is the product of two functions, x squared and tan x. So this is u and this is v, right? So by chain rule, divide the x will be equal to v, which is tan x, multiplied by the derivative of x squared, which is the u. So this becomes 2x plus u, which is x squared, multiplied by the derivative of tan x, and that will be sec squared x, right? So this is one of your basic derivatives, right? Differentiation of tan x will be equal to sec squared x, and I'm going to show you how that works in our next video, right? So by simplification, if we simplify this, we have 2x tan x plus x squared sec squared x, right, There is x here, there is x here. So we can factorize. So we have x into 2 tan x plus x into sec squared x, right? So that's the derivative of the product of x squared and tan x, right? Removing x from here, we'll be left with one of the x, right? Yeah, that's true. So we can go on to look at the two other questions. So I'm going to clean here to x raised to the power of 5 e raised to the power of x, right? Okay, so divide the x will be equal to, remember this is my u and this is my v, right? So divide the x will be equal to v, which is e raised to the power of x, times derivative of u. If we differentiate x raised to the power of 5, we'll get 5x raised to the power of 4, right? Plus u, which is x raised to the power of 5, times derivative of v. If we differentiate e raised to the power of x, it will still give us e raised to the power of x. Whenever you differentiate the exponential function, or you integrate e raised to the power of x, whenever you differentiate it or integrate it, you still have same thing. So this will still give us e raised to the power of x, right? Now by simplification, we have that this will be equal to 5x raised to the power of 4 e raised to the power of x plus x raised to the power of 5 e raised to the power of x, right? That's true. So we can see that x raised to the power of 4 is common here. There's x raised to the power of 4 here, and inside of x raised to the power of 5 there is x raised to the power of 4, right? So we can bring it out. So this will be x raised to the power of 4, right? Apart from x raised to the power of 4, something else is still common, right? Which is e raised to the power of x, e raised to the power of x. So bring that out too. So if we bring e raised to the power of x and x to the power of 4 from here, what will be left will just be just 5, right? Yeah. Plus here will be x. Okay, so that's the derivative of that function. I'll be taking the last question now, and so I'll have to clean this part. Okay, for the last question, y equal to e raised to the power of 5x into 3x plus 1. Okay, so remember, this will be my v and this will be my u, right? So divide the x will be equal to v, and what's my v? 3x plus 1. So 3x plus 1 multiplied by the derivative of e raised to the power of 5x. Differentiating e raised to the power of 5x is quite easy, although that's changed, but it's quite easy. All you need to do, if I differentiate 5x, I will get 5, right? E raised to the power of 5x. That's all it takes to differentiate that. But that's changed because this is function of a function. So we have 5 e raised to the power of 5x plus u dv divide the x. And what's my u? E raised to the power of 5x into derivative of v. So if I differentiate 3x plus 1, I will get 3. Because differential of 3x is 3, differentiation of 1 is 0. Every time you differentiate a constant, even if it is 1 million, you still get 0. So by expansion, we have, using this to multiply, we have okay, I think there is a better way we could do that. Yes, so we are bringing out e raised to the power of 5x, since it's here and it's here. So if we do that, we have e raised to the power of 5x into 3x plus 1 times 5 is still here, plus 3. When we bring out e raised to the power of 5x, we'll be left with just 3 here. So this will finally be equal to e raised to the power of 5x into 15x plus 5 plus 3, right? So this is finally e raised to the power of 5x into 15x plus 8, and that's the derivative of that product, right? So this is all about the product rule. If you find this video helpful, I need you to like, to subscribe, and then share to your friends, share to those around you. Till I come your way again, thank you.